You probably think the cloud is a magical, invisible place where your emails, banking apps, and AI-generated pictures of dogs playing poker live. But the cloud isn't in the sky. It's mostly just a bunch of incredibly loud, staggeringly hot warehouses. And right now, those buildings are quite literally drinking rivers. Over the last few years, artificial intelligence has taken over basically everything. From writing code to generating video, the AI boom is here. But when developers talk about things like serverless architecture, they are lying to you. Serverless is like saying boneless wings. There are still bones somewhere, usually in a chicken. And there are still servers somewhere, usually in a massive, sprawling complex known as a hyperscale data center. When an enterprise company configures massive Kubernetes clusters or deploys a new AI model registry, we tend to think of it purely as software. Lines of code floating in the ether. But artificial intelligence has a physical, devastatingly heavy footprint. It requires metal, silicon, land, and most importantly, immense amounts of electricity. Because AI doesn't just run on standard computer chips, it runs on highly specialized GPUs. And if you've ever tried to play a high-end video game on a laptop while it was resting on your thighs, you know exactly what happens when a computer does a lot of math. It tries to physically brand your legs. Now, multiply your scorching-hot laptop by about 100,000, stuff them all into a giant metal box in the middle of a desert, and you start to see the problem. To keep these servers from melting into expensive puddles of slag, they have to be cooled. In the old days, data centers just used massive air conditioners. They basically blew really cold air over the computers. But AI models are too powerful and run too hot for mere wind. So, the industry has aggressively moved to liquid cooling. Because water is fantastic at absorbing heat. The hot water is pumped away from the servers and sent to massive cooling towers, where a portion of it evaporates to carry the heat away. It's exactly the same mechanism as you sweating profusely while trying to assemble IKEA furniture, just on a much larger, multi-billion-dollar scale. But that evaporated water? It's gone. Poof! Evaporated back into the actual sky. And the sheer volume of water we are talking about is staggering. A typical hyperscale data center can consume anywhere from 3 to 5 million gallons of water every single day. That is the daily water consumption of a city of 50,000 people. To put it in personal terms, researchers estimate that every time you ask an AI like ChatGPT a series of 5 to 50 prompts, the data center physically evaporates about 500 milliliters of fresh water. So, asking an AI to write a passive-aggressive email to your landlord costs one standard bottle of drinking water. Conceptually, at least. Please don't actually pour water on your router. Which brings us to the twist. And it's geographically spicy. Where do you build these massive, water-guzzling buildings? Tech companies look for three things: cheap land, cheap electricity, and friendly tax laws. Do you know what kind of places usually offer all three? Deserts. Tech giants are quietly building the thirstiest buildings on planet Earth in the exact regions that have the least amount of water. Places like Arizona, Nevada, or drought-stricken parts of Spain and Chile. This has kicked off a literal, physical resource war. Tech companies are quietly sweeping in and buying up massive water rights, putting them in direct competition with local farmers and citizens. Imagine a local farmer named Jeb. Jeb wants to water his almond trees. But a trillion-dollar tech giant wants that exact same water to cool its servers so that an enterprise client in Ohio can dynamically scale their machine learning workloads. Guess who has more money to buy the water? Spoiler alert, it isn't Jeb. In 2023, this actually came to a head in Uruguay. During the country's worst drought in 70 years, the tap water in the capital city became so salty it was practically undrinkable. Right in the middle of this, it was revealed that a major tech giant was planning a new data center that would suck up millions of liters of the city's fresh water per day. The public flipped out. They organized massive protests, forcing the tech giant to completely redesign the facility to use a smaller, closed-loop cooling system. This is the hidden crisis of the AI boom. We treat artificial intelligence as infinite. A magic box where we type words and get infinite answers, infinite code, and infinite images. But down here on Earth, there is nothing infinite about it. The massive expansion of AI is running headfirst into the physical limits of our planet's resources. The power grids are groaning, and the aquifers are draining. It creates a bizarre environmental paradox. We are eagerly hoping that superintelligent AI will eventually help us solve massive global issues, like optimizing our power grids and fixing the climate crisis. But to build that AI, we are actively draining the power grids and heavily straining the local environment. Tech companies are now scrambling to find alternatives, investing in things like geothermal cooling, returning treated wastewater to municipalities, or exploring liquid cooling solutions that use specialized dielectric fluids instead of pure drinking water. Because if they don't, the digital revolution might just run out of actual, physical juice. So, the next time you look up at a real cloud in the sky, just remember, it is currently holding a lot less water than the one storing your data.